drawing the free body diagram. We will remove the zero force
Zero force
members
members
that are
that are
LB
LB
and
and
LC.
LC.
Let's find
Let's
out
find
how
out how
we got
we
the
got the
free
free
zero force
zero force
members.
members.
As we can
As we
see,
can see,
this
this
force
force
is
is
clearly a zero
clearly a
force
zero
member,
force member,
and
and
hence we
hence
can
we can
cancel out
cancel
this
out
one
this one
that is the
that is the
same
same
one
one
over here,
over here.
and hence
And
we can
hence we
also
can also
conclude
conclude
that
that
this
this
force is
force is
also a
also a
free
free
zero force
zero force
member.
member.
We can
We can
remove the
remove
zero
the
force
zero force
numbers
numbers
from
from
both the sides
sides
because
because
the
the
diagram is
diagram is
symmetrical.
symmetrical.
So
So
let's draw the
let's draw
new
the new
structure
structure
without the
without
zero
the
force
zero force
numbers.
numbers.
Over
Over
here we
here
can
we can
start by
start by
finding out
finding out
joint
joint
A
A
and
and
the
the
forces
forces
surrounding it.
surrounding it.
So
So
we have
we have
also
also
taken
taken
the
the
y
y
component of
component of
A
A
and the
and
y
the y
component of
component
G
of G
to
to
be
be
20
20
and
and
AX to
AX
be
to be
0
0
because
because
of
of
no
no
other X
other X
component
component
in the
in the
external
external
body.
body. So
So this
this
20 right
20
here
right here
is
is
AY.
AY.
Hey God, you wanna study right now? Now let's
Now let's
find out
find out
FAB.
FAB.
Uh, so
So
as we
as
know,
we know,
FAL
FAL
is
is
28.28
28.28
and it
and
is
it is
being
being
compressed.
compressed.
We will
We will
take
take
the X
the X
component of
component of
AL
AL
and
and
that is
that is
1 over
1
root
over root
2
2
and we
and
got
we got
that by
that by
Pythagoras
Pythagoras
theorem.
theorem.
Next we
Next
can
we
move
can
on
move
to
on to
joint C
joint C
and
and
we will
we will
find
find
force
force
CK.
CK. Next, we will find out force CD, and that is obvious to be 20. Let me tell you why. Because as we can see, AB is 20 and in tension, so and hence BC would be again 20 and in tension, and hence, uh, as we know, this member does not exist because it's a zero force member. No force exists in these members, and hence there will be no other x component about C. So this will be 20 newtons in tension. Next, we can find out forces about joint K. If we look at the diagram, so we will have two unknowns here. First one will be Kj. We know Kl as it will be the same as Al, right? And the second unknown will be Kd. So we will use two equations, that will be the x equation and the y equation of joint K in this. Over here we have taken a couple forces, namely, firstly we have taken Fkj, so this force right here, and its component in the y direction. We can find out that by again the Pythagoras theorem. This is the this so secondly we have taken the y component of Kl, that is in compression, so we have taken it positive. Then as we know Ck is 10 newtons, and as it is in tension, so it will be negative. And lastly, the y component of Fkd, that will be negative, as we will assume it is in tension, and the component will be found out by again Pythagoras theorem. Taking the length CD and Ck, we can find the length Kd. Let's move on. Then we will make the equation of the x component. Now we will solve for Fkd. So let's move ahead. and hence we found out FKT, that is 7.5, and in compression. Then we will find out FKJ right here. Let's move on. Again, this one is also in contraction. Finally, we will move on to joint J. Uh, Now that we have FKJ and F, we know F, we will find out FJD, because we assume that FKJ is equal to Fij because the diagram is symmetrical. We will take the vertical component about joint J. We have finished the problem for for uh, for the last, that is joint J. We have taken 23.55 to be positive because, as we can see over here, it will point, this will point upwards, and same, this will also point upwards. So the vertical component will be positive, hence we have taken that to be positive.